Hello everyone, my name is Toni Ramchandani. I'm currently working as Technical Delivery Head designated as Vice President at MSc INC. I work upon plethora of technologies like AI, ML, QA, DevOps, security ops, etc. So whatever comes in the technology field, I am responsible for that. I have 15 plus years of experience wherein I have uncovered almost every tool which I hear about and which I'm eager to know. So I uncover all of them. So that's about me. So now coming to the topic, vector databases. Vector databases are very key part of AI applications. We all know how AI is changing our world. You might be aware of the traditional databases, relational databases, which we all work upon. We know SQL, but we don't know that whether these tools are good with AI or how they help AI to achieve what AI is today. So the answer is no. Relational database or traditional database are not going to help you there. So here comes vector databases. Now just imagine that you need to store or train your model on video corpus, audio, or a lot of text. All of them is unstructured data. You cannot simply store them in a relational database. Let's assume I want to ask you to query an image. Okay. How would you do it? How would you store it? How would you retrieve it? How do you update it? You cannot do that. Simply cannot in traditional databases. Even if you find the hack, it is not worth spending the money and the time. So enter vector databases. These are the basically one of the databases which are key aspect of storing data. I have written a detailed article about vector databases on Medium, which you can go and read. You will find a lot of information over here, which speaks about each and every bit and implementation of vector databases. So we are going to talk about its introduction, the core concepts, the types, use cases, and how to set up implementation, etc. So these are the specialized databases designed to store, index, query, vectorized data. Now, what you mean by vectorized data? I'll take you to the school lane, your school memory lane. You know what is scalar, what is vector. If you don't know, I'll just remind you. Scalar is just a value with a magnitude, but vector is a value and direction combination of both combined forms of vector. Imagine a 2D point in space, it's vector, right? So over here, what happens? Every data can be converted into these vectors. Imagine just like converting a video or text or image into a vector, and then because it's numbers now, AI understand numbers, system computers all understand numbers very easily. So they talk to the numbers rather than talk to the thing which is there. So there are certain features in there: similarity search, high dimensional data support, very scalable and efficient indexing. So these are some of the very important aspect and features of it. Similarity search is basically gives you the similar answers. So for example, maybe you are looking for to buy a something on a e-commerce website. So it is going to suggest you the similar items. For example, if you go and buy or look for the chair, it is going to suggest you the different chairs you have in the store, or maybe with respect to your preferences. High dimensional data support. As I said, I mean every vector is of nth dimension. N is a very big number over here we are talking about. Imagine what ChatGPT's embeddings are generated are of 21,000 by default. 21K is a very big number. We cannot even see. Scalable and efficient indexing. So because these are numbers, so these can scale to anything. Okay, these take not a lot of memory. What with respect to what it has in terms of videos or audios. So it's just a number. So it is very much scalable and very much indexing is possible over there because we are just dealing with numbers over here. Which databases are available in the market? Widely used open source is Milvus and Chroma. Chroma we are going to implement over here, and Vespa, Quadrant, Marco, a lot of them are there. You can go and research about it. Pinecone and Waviate as the closed source, and PostgreSQL, which you might be aware of. This database support vector search basically. Again, it's open source, but just supporting your vector search. It's more of a traditional database. And then Redis, Elasticsearch, these are the closed source which support your vector search. What is the core concept behind it? How it stores that? So basically, a vector I spoke about. Now, what is embeddings? Embeddings is basically a numeric representation of data used to capture text, images, etc. Now, what vector it is converting into? For example, a sentence is converted into a vector, then vector is called as an embedding. Okay, that particular list of array which a vector can have, like it most of the time it goes between -1 to 1. So just imagine like 0.28, 0.32, 0.67 for one word to nth number. We're going to see this. So over vector space, you can see in this diagram that wolf, dog, cat. So all of them are in the almost in a similar um, space. Banana, apple, because they are fruit in different similarity search. I talked about it. If you're looking for chair, it is going to give you the chairs. Now, how it does that? It is going to it does that using by calculating the cosine similarity or Euclidean distance. So cosine similarity is basically, again, I'll take you to the memory lane of your schooling. So it goes between -1 to 1. What are the indexing methods? Approximate nearest neighbor. So it is going to yield the nearest neighbor basically. That's how it is going to create the indexing. And hierarchical navigable small worlds. I want you to read more about them whenever you get time. A very much detailed mathematical approach is available over there. Types of databases I spoke about just to diversify more. Pinecone and Waviate are cloud based, and Milvist and Vespa are on premises. Vespa again is a hybrid. What are the use cases for it? Image recognition. Now, for example, let's say that you store one image, and just imagine how Google is going to give you the similar images when you search on it, right? So you search for, let's say, vector databases, click on the images, it is going to give you the identical images which are in that context. Recommendation system, everybody has seen at least one recommendation or used it. Netflix or any e-commerce, Amazon, so all of them are using vector databases which suggest you similar movies, similar songs, similar podcast, similar products which you follow every day. Semantic search. So text can be represented as vectors, provide you more relevant search results. Anomaly detection. Now, because this works on clustering the data, so if anything goes out of that cluster in the same pattern, can be an anomaly, right? So this can be used over there. This is a documentation of ChromaDB, and you can read more about it, how it works basically over here. A lot of informative and a detailed documentation is available. So this is how it works in a nutshell, that your AI app is there, user queries, then your embedding models generate the embeddings. Embeddings look like this, like array of the numerical values. And then in the document, this document is again converted into embeddings. Your queries converted into embeddings, and then similar sentence are returned and provided to the LLM, and then LLM answers the user. So that's how typically an AI application works. And let's implement now. So over here, you need to use this command: pip install ChromaDB transformer torch. This is Google Colab. If you don't know about it, read about it. It's very good tool to use, free to use, and Google has provided a lot of features. You can directly run your Python code. Most of the things are already installed. Whatever is not there, you need to install. For example, ChromaDB is not there, you need to install. Pandas is there, you don't need to install. Python is there, you don't need to set up. So once you run this, you will be connected to a runtime. When you run this, this will be executed and it will install if there is no problem. So this is about the AI architecture I spoke about. Now, what is this ChromaDB? I told you, right? It is going to store the high dimensional vector data in multi-dimensional space, and it can store a lot kind of things like images, videos, audio, unstructured text like PDF, CSV, Excel data, etc. And then once you install it, you need to import the necessary libraries like ChromaDB, Transformer, Torch, NumPy, and then from Transformer, basically it's kind of a backbone of what generative AI is today. From there, we need tokenizer and BERT model. These are going to generate the embeddings for us. Every sentence can be diluted in a token. So I'm going to cover that. Over then, we are going to initiate the ChromaDB client with this method, ChromaDB.client method. And then if we have the existing collection, which is existing database available, then we are going to delete it in this tutorial, because otherwise it will just simply cannot create new one. And once it is done, we are going to create the collection with some name. Over here, we are naming text similarity collection. And then we are going to create tokenizer. So from BERT tokenizer, which is an open source available on Hugging Face. So we are going to use this model and then tokenizer model, and then we are going to call an open source LLM model, which is BERT model. And these are free to use. You can run this on your machine. Then we are going to set our model to evaluation mode, so that it disables unnecessary or other training types of layer which we don't need in this case. So we are going to disable that with this method. Now we are going to generate the embeddings. So everything as a text which we are passing over here will be generated as an embedding. So first, the input, user provides the input, so that is going to generate the tokens for that, and then tokens are basically a number. So, for example, the cat sit on the mat. So the cat is number one. The is one. Cat is two. Sits is three. So so on and so forth. The words or subwords or character level tokenizing can happen over there. We are doing a word level tokenization over here, and then we are going to create the embeddings with torch model, and we are going to create in a numpy array, because as I said, it is going to be a high dimensional array. So we are going to convert them to a list so that it's easy to use over here. And then let's assume this is my corpus of text which I want to test in this case. So I am creating a database with these many lines of data into it. So it is far different from traditional database. There is no table over here. The cat sits on the mat is one of my line in the database. A quick brown fox jumps over the lazy dog. Another line, artificial intelligence is transforming the world. Third line, so on and so forth. If you want, you can add more lines over there. Now what we are going to do, we are going to retrieve the similar sentences from here by providing the user input. So then this is all of this text will go through the embedding model which we created, and then it is going to generate the embeddings for us, and it is going to store this. Now just assume that user queries machine learning is rapidly evolving field, and then this query is also converted into the embeddings which I told you in previously, and then this is going to give the result by querying the collection with the input embedding, and we want top three result, let's say. So then we are going to just print our result. Let's see what the output comes over here. You can see. So what is the, let's understand what is the user query. User query is machine learning is rapidly evolving field. So this is the user query. Let's assume what from the collection what database is retrieving us. Data science is fascinating field. Deep learning has led to significant breakthrough in AI, and AI is transforming the world. So if you recall, there was a sentence called as the cat sit on the mat and the fox one. It is not here. It is going to retrieve the similar sentences. And if we are keeping it to top three, we can keep to top one or top two, and you can experiment with this. You can put your data over here and you can try it out. Okay. So this is about it. If you have any questions about it, you can reach out to me on my LinkedIn and you can ask me there if you want this code. Again, you come on LinkedIn and I'll share with you the GitHub repository for this. Bye for now.